This is my introduction to computer science. Well, what even is computer science? Computer science is the study of computers and computational systems. It involves the understanding of theoretical algorithms and the practical implication of these theories through hardware and software. It includes areas such as software development, systems architecture, artificial intelligence, data science, cybersecurity, and more. Now, I just want to show you just some brief history of computers. So, we have early mechanical computers, such as the abacus and the Pascaline. This is the abacus, this is the Pascaline. Then we move on to the 19th century. Charles Babbage's analytical engine, Ada Lovelace's algorithms. Here's Charles Babbage, his engine, and this is Ada Lovelace's. And the 20th century, Alan Turing and his Turing machine were introduced. This is Alan Turing. The ENIAC, which is right here, and the development of programming languages like Fortran and COBOL. Now, moving on to the modern era, we have the rise of personal computers, the internet, and mobile computing. Here's a computer, here's a flip phone. Now, I want to talk to you about the major branches of computer science. There's 5 major branches, and they all go into subsections. We got theoretical computer science, hardware systems, software systems, artificial intelligence, and human-computer interaction. Theoretical computer science has 3 subcategories: data structures, algorithms, and computational theory. You can easily describe theoretical computer science with 4 points: algorithms, data structures, computational complexity, and the automata theory. Algorithms are steps or procedures for solving problems or performing tasks. Data structures are ways to organize and store data efficiently, like arrays, linked lists, and trees. Computational complexity is the study of the efficiency of algorithms, the time and space it takes. Automata theory is the mathematical study of abstract machines and problems they can solve. Let's move to software systems. Software systems has 3 subcategories as well: software engineering, databases, and operating systems. When developing software, you can do it in 6 steps. Requirement analysis, which is gathering and analyzing user requirements. Design, which is creating system architecture and designing documents. Implementation, which is writing and compiling code. Testing, which is ensuring software works as intended. Deployment, which is releasing software to users. And maintenance, updating and fixing software post-release. These are the steps that you use to make software. Any software usually goes through these 6 steps, because you first start off with figuring out what we need. Then we start designing an architecture, a base. Then we write and compile the code to it. Then we ensure it works properly. Then we release it. Then we update it. It's pretty similar. You can probably figure out that most apps do this. Let's move to hardware systems now. You got networks, computer architecture, and embedded systems. Let's look over computer hardware. There are 4 main categories: CPU, memory, input/output devices, and networking devices. CPUs, or central processing units, are like the brain of the computer. They execute instructions that you give it. Memory, there's two types of memory. RAM, which is random access memory, which is temporary storage for data currently being used. Storage, which is permanent storage for data, like HDDs or SSDs. Input/output devices are like keyboards, mice, and monitors, also printers. And network devices are like routers, switches, and modems, which connects you to the World Wide Web. They make it easier for you to transfer information from one place to another. Let's move over to artificial intelligence. Artificial intelligence also has three subsets: neural networks, robotics, and machine learning. AI is the simulation of human intelligence and machines. It's trying to replicate how humans think. It's pretty much trying to be a human brain. Machine learning. Algorithms that allow computers to learn from data. It's pretty much trial and error. They give you a set of information, and based on that, they try something, see if it works well. If it doesn't, try something else. They see what does best, and then keep on doing that with slight changes. Deep learning. Subset of machine learning using neural networks. Applications of AI include diagnosis and personalized treatment in healthcare, fraud detection and algorithmic trading in finance, recommendation systems and content generation in entertainment. And yeah, there's lots of applications, much more to yet be used. There's many more implementations that could be used for many things. Let's move over to human-computer interaction. This only has two subcategories: usability and user experience design. Human-computer interaction can be very easily summarized in 4 points: usability, user experience, design principles, and user interface. Usability is how easily users can use your system. User experience, or UX, is overall experience of a person using a system. Design principles include simplicity, consistency, and feedback. User interface, or UI, is design of the visual elements of a system. Now that we've covered all the major branches, let's talk about programming. Programming languages there are lots of them. Some are high, some are low, some don't even make sense to me. But let's talk about program languages. Program languages are languages used to give instructions to a computer to perform a specific task. There are two types of programming languages: high-level languages and low-level languages. High-level languages include Python, Java, and C++, which are more abstract and closer to human language. It's harder for the computer to actually decode. It takes more. It's harder for it. And then you got low-level languages, which are like assembly and machine code, closer to the hardware itself. It's almost like the computer itself. Examples include Python, Java, C++, and JavaScript. Python is easy to learn, widely used in web development, and is used in data science. Java is object-oriented, used in enterprise applications and Android development. C++, high performance, used in systems and softwares, and used in game development. JavaScript is essential for web development and interactive web pages. So now you got some career opportunities. You have software developer, data scientist, systems analyst, network engineer, cybersecurity expert, and many more. Software developer, they design, code, and maintain software applications. Data scientists, they analyze and interpret complex data. Systems analyst, analyze and design IT systems. Network engineer, design and manage network infrastructure. Cybersecurity expert, protects systems and data from cyber threats. Some future trends that may be seen are quantum computing, advanced AI, Internet of Things, and blockchain. Quantum computing is harnessing quantum mechanics for computation. Advanced AI is more sophisticated and more autonomous AI systems. Internet of Things are a network of interconnected devices, which already kind of exists, but instead of being like basic things like computers and cell phones, can be applied to many more things like houses, lock systems, thermostats, and many more. And then blockchain, which secures and decentralized digital ledgers. Some further learning resources you might want to use are Coursera, edX, and Khan Academy. Some books, Introduction to the Theory of Computation by Michael Sipser, Artificial Intelligence, A Modern Approach by Stuart Russell and Peter Norvig. Some websites are Stack Overflow, GitHub, and W3 Schools. And some communities are local user groups, online forums, and hackathons. And, well, thank you. This is my first ever video. Thank you for watching it. Thank you for enjoying it. Just thank you for clicking on it in general. I don't care if you subscribe. It would be very appreciated, but you don't have to. You can do whatever you want. Hopefully you felt good about having just a little bit more information about computer science. This is only an introduction.